Morning, everyone. Sorry for
Yes,
the
sir.
delay.
I'm
There
the
was a
host.
circular motion. This is some problem now. The horizontal table. Okay. That is really spotting. Morning, everyone. Good morning, Omkar. All right. So what I want to say over here is, it's a horizontal table, and this table is rotating about the axis with the angle velocity omega. All right. It's a graph at a distance of r. Coefficient of friction is mu. So if I see from above, and this is the bar that the graph is going in a circle because table is rotating with omega. Correct? That's from above. Now, I will see the direction of friction and calculate the equation of motion. Students, if this particle is going in a circle, it is having a centripetal acceleration. Because it's going with constant omega, its alpha is zero. So its tangential acceleration is zero. You have a tangential speed of v naught, which is equal to r omega. But it will have a centripetal acceleration because if the particle is taking a turn, whenever particle takes a turn, it will have a centripetal acceleration. That's what we have discussed about. We discussed that already. Now, when there is centripetal acceleration like this, there has to be some force which is responsible for the centripetal acceleration. And that is centripetal force. I hope my voice is clear now. All right. So there has to be some force which is responsible for the centripetal acceleration here. And what is the centripetal acceleration here? It's omega square r. So if I write equation of motion, and the friction, the only possible force on the surface is friction. So friction is responsible for this centripetal acceleration. So friction will be acting inward towards the center. So friction
Sir,
Fs.
sir. సార్
Sorry,
ఒమేగా స్క్వేర్ ఆర్ ఎందుకుంది సార్
omega square r.
ఆన్సర్?
నిన్న చెప్పాను కదా మీరు నిన్న. ఓకే. Centripetal acceleration is v square by r, which is equal to v is equal to r omega రాస్తే r omega square by r. So r square omega square by r gets
ఎస్ సార్.
r gets cancelled out. I'll get omega square r.
ఒమేగా స్క్వేర్ ఆర్.
All right. Is it okay?
ఎస్ సార్.
All right.
ఎస్ సార్.
So ఇప్పుడు అదే నేను v0 ఇస్తే I would have written v0 square by r, but I've written omega. I've given omega, so I've written omega square r. I can either write v square by r or omega square r, right? All right. Now, friction is the only force which is responsible for the acceleration. So friction should be in the direction of centripetal acceleration. Now my friction now is Fs. F is equal to m times omega square r. And what kind of friction is it? Is it kinetic friction or static friction? It is static friction because there is no relative motion between the block and the surface. Surface ఇలా మూవ్ అవుతుంది. Surface rotate అవుతుంది, on which there is a block kept. So with that, block is also rotating. And that is block is taking a turn because of friction. So friction is responsible for the turn, centripetal acceleration. So friction is the centripetal force there. And that friction is m omega square r now, which is equal to, which is static friction, which should be less than the limiting friction, limiting static friction mu mg. Coefficient of static friction is mu. So less than mu mg, m gets cancelled out. So omega square r is less than mu g. So omega should be less than mu g by r under root. So what happens if omega is greater than this or equal to this? When omega is equal to this, my block is on the verge of slipping. If omega is greater than this, my block slips because friction is no more sufficient to provide the centripetal acceleration. Do you understand this?
ఎస్ సార్.
All right. All right. Now, if you note one thing in a conical pendulum, when you have a conical pendulum, this alpha is measured from the g vector. G vector is vertically downward. This will rotate in a circle perpendicular to the, in a plane perpendicular to g bar. So that, so particle rotates in a circle in a plane perpendicular to g bar. So that's what is happening in conical pendulum. So here, centripetal force responsible for the turn is T cos theta, T sine alpha. Vertical equilibrium, T cos alpha is equal to mg. From there, I got tan alpha. All right. So that's all is fine. We have done all these things. We have derived tan alpha is equal to omega square r by g. But the point which I didn't convey then is this plane of rotation of the particle is perpendicular to the g vector, g bar. So if at all I have got this in a car, which goes towards right with an acceleration a, or acceleration g, let's say. So my g effective is not vertical, but g effective is at an angle of 45 degrees with the vertical. That time my conical pendulum will rotate not like this, but like this. Because this is g effective, which is g root 2. My plane of rotation of the particle, conical pendulum, is perpendicular to g bar, g effective. So my conical pendulum rotates in this direction. So whole of my universe now inside the car is now tilted because my g effective is tilted. If particle को project చేస్తే it will be parabolic with respect to axis of the parabola parallel to g bar. If at all a particle has to come to his own hand, I should throw it along with 45 degrees so that it goes straight up, stops and comes back. So my whole of the universe is now tilted. ఏదైనా experiment చేసినా ground మీద చేసినప్పుడు all the parameters are now with respect to this G effective bar, which is 0 to at an angle of 45 degrees with the vertical. All right, is it clear? I didn't mention this yesterday. I'm mentioning it now. Any doubts so far? Students, any doubts so far?
No, sir.
No, sir.
Okay. So can you now find angle alpha or tan alpha with respect to this tilted axis? Can we do that? Yes. Let this be T naught. So T naught sine alpha is m omega square r. T naught cos alpha is equal to mg effective or mg root 2. Mg effective. Why is it mg effective? Because my force now will be in this direction. That is pseudo force and resultant of pseudo force and gravitational force will be in this direction. So it will be towards an angle of 45 degrees with the vertical. M times g root 2 will be my equivalent to gravitational force. Force equivalent to gravitational force. Because whole of my universe is now tilted. Gravitational force మాట్లాడితే నేను ఇలా మాట్లాడతాను at an angle of 45 degrees with the vertical. If I now divide these two, T naught gets cancelled out. Tan alpha, M gets cancelled out. Omega square R by G effective. Where alpha is the angle measured from this new vertical. It's not a vertical now, but an inclined line. Make an angle of 45 degrees with the vertical. So alpha is measured with respect to that line. 20. This is alpha. It is not with respect to vertical. So with respect to vertical, my angle would be angle alpha minus 45 is the angle made with respect to the vertical. This position will make an angle of alpha. All right. These are all things you can measure it from the diagram itself. I don't have to mention it again and again. So alpha is measured with respect to this new vertical, which is tilted angle, making an angle of 45 degrees with the vertical. But how do you get 45 degrees? Why did I get 45 degrees? Because my pseudo acceleration is towards right, g. So pseudo force will be towards left. So net will be in this direction. So this is G and this is G, G root 2. What if this is A? It is not G, but it is A. So my 45 is not 45 now. It is tan inverse of A by G. So alpha is measured with respect to tan inverse of A by G. Do you understand this? Tan inverse A by G ఎందుకు వచ్చింది అర్థమైందా? Is it okay? Have you understood why it is tan inverse A by G?
No, sir.
It is tan inverse A by G because my new vertical is tilted at an angle of, let's say, theta. Theta is equal to tan theta is A by G. So tan inverse A by G is my new angle, new vertical. So alpha is measured with respect to that new vertical. Why am I saying new vertical every time? Because my whole of my universe is now tilted as if my G effective is at an angle of theta with a vertical, and this is my new vertical. Particularly at an angle of tan inverse A by G, is then go back, go in straight line, come back to the hand, its own hand. As if I throw a particle vertically upwards, it will go up and come back to its own hand, my own hand. Similarly, same thing happens when I throw a particle at an angle of tan inverse A by G in that car. That's why I'm saying it's new vertical. All right, Omkar. What's your doubt, Omkar? You haven't understood. What have you not understood? I didn't see your message. I saw your message just now. Yeah, can you type your doubt or can you ask what is that you want? All right, all right. I'll repeat. See, what is happening is ఒక particle ని కార్ లో ఈక్విలిబ్రియం లో పెడితే it will make an angle of theta naught such that MA naught mg and this resultant MA naught by mg should be equal to tan theta. Right? MA naught by mg is tan theta. So I'll get theta from there. So theta is tan inverse A naught by G. Now what I mean to say is, if I make this pendulum, this bob into a conical pendulum ఏంటి? I told you just now that the plane of rotation is perpendicular to the G effective acceleration. So effective acceleration is making an angle of theta naught with this vertical. So my pendulum will rotate like this. Do you understand this? ఇక్కడ వరకు అర్థమైందా, ఓంకార్? That my
Yes,
plane of
sir.
rotation will be perpendicular to the G effective. G effective ఎలా వచ్చింది నాకు? Pseudo force MA is towards left, mg is downward, MA by mg is tan theta, m gets cancelled out, tan theta is A by G. So theta is tan inverse A by G. Now when this is a conical pendulum అంటే ఏంటి? This bob while rotating generates a cone. That's why it's called conical pendulum. A cone generate అవుతుంది ఇలా. All right. I don't have a pendulum right now. I'll get a pendulum by tomorrow. All right. I'll show you this pendulum practically with I have a pendulum, but I'll get it by tomorrow. Don't worry. So that it becomes easy for you to understand why it's called a conical pendulum. That's pretty easy to understand. You don't have to look at a pendulum to understand why it's called a conical pendulum. Omkar, is it okay now? Now this angle alpha is measured with respect to this new vertical. I'm calling it new vertical because now vertical, if the car moves cheyakunte, vertical is in this direction. G effective is downward. If car is going towards right with an acceleration A or G, my G effective is at an angle of theta, which is tan inverse A by G. If A equal to G, theta is 45 degrees. That's what I considered in the last case. Now, if this is alpha, I'll have T sine alpha is equal to m omega square r. T cos alpha is equal to mg effective. If I divide these two, m gets cancelled out, t gets cancelled out. I'll have tan alpha is equal to omega square r by g effective. Alpha is tan inverse of omega square r by g effective. So this alpha is measured with this new vertical. This inclined direction nunchi alpha measure chestunnanu. Conical pendulum lo. Always I measure alpha with respect to the g effective direction. When this car is not moving, my conical pendulum is in that plane of rotation is horizontal because that's perpendicular to the g effective, which is vertically downwards. G is vertically downward. But when the car is moving, my g effective is inclined. My plane of rotation will be perpendicular to this direction. So ఇలా ఉంటుంది rotation. Horizontal ఉన్నప్పుడు ఇలా ఉంది. When it's inclined, when my g effective is inclined, my plane of rotation will be like this. So everything now will shift, will be tilted with respect to the vertical by an angle of theta, which is tan inverse A by G. All right. Okay, that is fine. Now let us understand. Look at the students. If a particle is going in a circle with respect to ground, see, whenever I draw an FBD, I should think of a reference frame first. And without mentioning, I've done it using a reference frame fixed to the ground. All right. If I don't mention, the reference frame is fixed to the ground. But now, if the reference frame is fixed to the circle itself or to the axis which is rotating with omega naught, then what happens? The particle will seem to be stationary, right? As a particle goes along the circle, with respect to ground, it has a centripetal acceleration, which has a centripetal force m times AC. All right. There is a centripetal force, a real force, which is acting on a particle, which is making it turn. It's a real force. But with respect to the circle, the particle seems to be at rest. With a real force acting on it, a particle can be at rest only when there is a pseudo force. And that pseudo force will be opposite to the direction of acceleration of the reference frame. My reference frame is a rotating reference frame. Till now, we have been dealing with a reference frame which is moving translationally with an acceleration A towards right, towards left, upward, downward, or at an angle translationally. But now it is rotating. My rotating reference frame is a non-inertial reference frame, that is the accelerating reference frame, because of which I will have to apply a pseudo force on the particle opposite to the direction of acceleration of the reference frame. What is the acceleration of the reference frame? Centripetal acceleration is the acceleration of the reference frame, AC towards left. Pseudo force will be MAC towards right. Here is the centripetal force, which is a real force. But with respect to this reference frame, the particle is at rest. That can be explained only with the existence of a pseudo force. Why is it a pseudo force? Because it is coming into picture to explain the equilibrium condition with respect to the reference frame. ఈ reference frame లో నేను మాట్లాడితే particle is in equilibrium, but the only force is acting is real force Fc, which cannot be in equilibrium. That means I cannot apply Newton's laws in this reference frame. So I'll have to apply some another mathematical term, m omega square r. Why is it m omega square r? M times acceleration of the reference frame. Acceleration of the reference frame is omega square r towards the center. So pseudo force will be away from the center. So pseudo force in a reference frame, in a rotating reference frame, is called centrifugal force. So centrifugal force is a pseudo force which is acting away from the center and is equal to mass times acceleration of the particle, acceleration of the reference frame, which is equal to omega square r. All right. So centrifugal force is nothing but a pseudo force which is applied on a particle when you draw the FBD or NMAD with respect to the reference frame attached to the circular reference frame, rotating reference frame. అదే గ్రౌండ్ నుంచి మాట్లాడితే ఎలా మళ్ళీ మాట్లాడతారు? There is a centripetal force because of which there is a centripetal acceleration and the particle is going in a circle. So that makes complete sense. But with respect to this reference frame, particle is at rest despite there being a centripetal force. So that is explained by saying that this is being counterbalanced by a pseudo force, which is m omega square r acting on the particle. From ground reference frame, I'll write Fc is equal to m omega square r. From this non-inertial reference frame, circular reference frame, I write Fc minus m omega square r equal to 0. Look at this. These two are mathematically same, but physically different. So Fc is m omega square r. Fc minus m omega square is 0. If I take this to the right hand side, I'll get Fc is equal to m omega square r. But this means the particle is in motion, is an accelerated motion. But this means the particle is in equilibrium. Net force is equal to mass times acceleration, which is 0. Here, net force is equal to mass times acceleration, which is m omega square r. Omega square r. Sorry. So force is equal to mass into acceleration here. Net force is equal to 0 here. All right. This is from non-inertial frame, circular reference frame, rotating reference frame, and this is some ground frame, which is inertial reference frame. Inertial, non-inertial, non-accelerated, accelerated, ground frame, rotating reference frame. All right. So we can solve anything either from this frame or this frame. If we talk about the just now particle which is rotating on a rotating table, and which was rotating because of friction force F, I can solve it with respect to rotating reference frame, saying that friction F minus pseudo force m omega square r equal to 0. So F is equal to m omega square r. That's what I got from ground reference frame as well, where F is limiting value of S in mu mg is equal to m omega square r. So omega square is less than mu g by r. So omega is less than root of mu g by r for the particle to remain in equilibrium with respect to the rotating reference frame. We got the same conclusion using ground reference frame just now, a while ago. But I'm doing the same thing with respect to the circular rotating reference frame, which is non-inertial reference frame, where I have to apply a pseudo force to explain the equilibrium of the particle. There is a friction force acting. Despite that, the particle is in equilibrium. All right. Okay. Now we can also understand conical pendulum based on pseudo force. With respect to this rotating reference frame, which is rotating with omega naught, I have a pseudo force m omega square r, gravitational force mg, and tension force here T. Particle is in equilibrium in this condition. Under these forces, particle is in equilibrium with respect to the rotating reference frame. So particle will seem to be at rest with respect to the rotating reference frame. But with respect to ground, it's rotating with omega. So, but with respect to the omega frame, rotating reference frame, the particle is at rest under these action of these forces. What are the forces? Two real forces, tension and mg, and the third force is pseudo force. Let us now resolve the forces. T sine alpha minus m omega square r equal to 0. This is T sine alpha, and this is T cos alpha. T cos alpha minus mg equal to 0. So I'll have tan alpha is equal to omega square r by g. So alpha is equal to tan inverse of omega square r by g. That's what we got using ground reference frame as well. But here I'm using pseudo force concept and getting to know the same result. All right.
Yes, sir.
Okay.
Yes.
Okay, now let us understand a problem. I've got a rod along which there is a bead which can slide along the rod freely without friction. So there's no friction now. This rod is rotating about this one with angular velocity omega. It is initiated at a distance of L. I have to determine, see, what is happening now when this rod is rotating like this. With respect to the rod, there is a pseudo force on it, which is m omega square r, m omega square L, because of which the particle will start moving towards right. Right? From ground frame, tarvata cheddamo. This problem becomes difficult from ground frame. All right, don't think about it right now. We'll solve this problem using rotating reference frame. Ground frame నుంచి ఎలా అవుతుంది, ఎలా అనలైజ్ చేయాలి తర్వాత చేద్దాము. All right, that will do it eventually once you get better exposed to better problems. All right, now what is happening? Pseudo force is acting towards right, because of which the particle starts moving towards right. So let's say the particle goes to a distance of x, starts from L naught, but goes to a distance of x. So pseudo omega square x. Why is it omega square x? Because my accelerator of the reference frame is omega square x, omega square r. So pseudo force will be m omega square r. So force is dependent. The question is how to determine the velocity when it reaches a distance of 2L. When the bead reaches here, from here, started with v equal to 0, start from rest. What happens? Like, what is the velocity when it reaches a distance of 2L? Students, a variation of this problem advanced in the last time, not last time, some time ago, somewhere in 2018 or 19. Some variation of this problem advanced వచ్చిndi. We'll discuss the problem as well in next class. But today we'll just understand how to get the velocity as a function of x, or how to get the velocity when the particle reaches 2L naught from this end. All right. So look at this. My force is varying with x. So acceleration is varying with x. So when there is a very acceleration, I'll have to use integration. I'll have to use v du by dx, du by dt, and so on.
Yes.
Okay, now let us see what is the pseudo force acting on it, m omega square x. So Fp pseudo force is equal to mass times acceleration. So m omega square x is equal to mass times acceleration. Mass gets cancelled out. So A is equal to omega square x. So A I can write it as v dv by dx is equal to omega square x. Now I'll take dx to the other side. I integrate this. When x is L, velocity is 0. When x is 2L, I have to find the velocity of the particle, v. Can you integrate this and tell me what is the velocity of the particle at 2L? Integral v dv is v square by 2. Integral x dx is x square by 2. So don't worry about the integration formula. Just apply the formula. Integral x dx is x square by 2. దాని డెరివేషన్ ఏమో మీరు క్యాల్కులస్ లో చేస్తారు.
Sir, is it
Sorry?
2 2L not W not, sir? Omega not.
Okay, let's do it.
2L not omega not.
V square by 2 under limits 0 to v is equal to omega square x square by 2 under limits L naught to 2L naught. 2 gets cancelled out here. I'll have v square is equal to omega square into 2L square minus L square. How much is 2L square minus L square? 2L whole square minus L square.
3L square, sir. 3L square,
Right.
sir.
Right, 3L square. So v square is equal to 3 omega square L square. So v is equal to root of or omega L into root 3. So it starts with 0 velocity and achieves a velocity of omega L into root 3 when it reaches a distance of 2L. All right. Now the question is, let's say this is an infinite rod. We are coming closer to the advanced question. All right, slowly we are modifying the question and coming to that advanced question. I've got an infinite rod. All right, find out with respect to x, like what if instead of 2L, I have to find out a general variation of x. So what do? I'll integrate from L naught to x. So what is the expression I get? V square is equal to omega naught square into x square minus L square. This is the expression I get. So I get v square minus omega square x square is equal to, or I'll write omega square x square minus v square is equal to omega square L square. So what kind of equation is this? What kind of equation is this, students? A with respect to x is linear, omega square x వస్తుంది నాకు. A with respect to is linear function. V with respect to x is what kind of function? ఇది చెప్పండి, conic section. It is a conic section, but what kind of conic section is it?
Sir, is it 30?
Uh-huh. Think again. ఎలా డిసైడ్ చేస్తారు సర్కిల్ అని? ఎలా డిసైడ్ చేశారు సర్కిల్ కాదా అని, సర్కిలా కాదా అని? హౌ డు యూ డిసైడ్? లైక్ వాట్ ఇస్ దట్ ఫ్యాక్టర్ విచ్ టెల్స్ యూ ఇట్స్ ఎ సర్కిల్? సర్కిల్ అంటే ఎలా వస్తుంది? ఎక్స్ స్క్వేర్ ప్లస్ coefficient of x square and y square should be equal, and there should be a plus sign. స్టూడెంట్స్, ఈ గ్రాఫ్ మనం చేసాం, గుర్తుందా? ఏఎక్స్ గ్రాఫ్ చేసాం మనం. ఏఎక్స్ గ్రాఫ్ చేసినప్పుడు కోనిక్ సెక్షన్స్ చూపించాను, చెప్పాను. ఆల్రైట్, సి దట్స్ ద ప్రాబ్లమ్ వీఆర్
Yes,
హ్యావింగ్.
sir.
దట్స్ ద ప్రాబ్లమ్ వీఆర్ హ్యావింగ్. యు ఆర్ నాట్ గెటింగ్ టైమ్ టు రివైజ్. మీరు రివైజ్ చేస్తే బాగా చేయగలుగుతారు, మీరు బాగా ఆన్సర్ చేయగలుగుతారు. బట్ థింగ్ ఇస్, యు ఆర్ నాట్ గెటింగ్ టైమ్ టు రివైజ్. రివిజన్ కోసం టైం దొరికితే యూ విల్ సి దిస్ ఇస్ ఆల్ ఐఎమ్ డూయింగ్ అగైన్. ఇప్పుడు ఫోర్సెస్ తో చేస్తున్నాను, అప్పుడు యాక్సలరేషన్ తో చేశాను. I've done acceleration versus x graph డ్రా చేసి, పార్టికల్ ఇక్కడ నుంచి ప్రొజెక్ట్ చేస్తే ఎక్కడ వరకు ఆగుతుంది, ఇక్కడ నుంచి ప్రొజెక్ట్ చేస్తే ఎక్కడ వరకు ఆగుతుంది, లెఫ్ట్ కి ప్రొజెక్ట్ చేస్తే ఏమవుతుంది, వదిలేస్తే ఏమవుతుంది, రిలీజ్ చేస్తే ఏమవుతుంది, ఇవన్నీ డిస్కస్ చేసాం మనం ఏఎక్స్ గ్రాఫ్ డిస్కస్ చేసినప్పుడు. అండ్ there are two kinds of AX graphs we have discussed. One is this way, one is this slope, one is this slope. గుర్తుందా?
Yes, sir.
ఇలా రిలీజ్ చేస్తే పార్టికల్ ఆసిలేట్ అవుతుంది, బట్ ఇలా రిలీజ్ చేస్తే పార్టికల్ దూరం ఇన్ఫినిటీకి వెళ్ళిపోతుంది అని అన్ని డిస్కస్ చేసాము. సేమ్ థింగ్ ఐమ్ డిస్కసింగ్ ఇన్ టర్మ్స్ ఆఫ్ ఫోర్సెస్ నౌ, ద కాజ్ ఆఫ్ ఇట్. అప్పుడు ఎఫెక్ట్, ఓన్లీ ఎఫెక్ట్ గురించి మాట్లాడాము, యాక్సలరేషన్ గురించి. బట్ నౌ వీఆర్ టాకింగ్ అబౌట్ ద ఫోర్స్ ఆఫ్ ఇట్, కాజ్ ఆఫ్ ఇట్. అయితే సేమ్ ఈక్వేషన్స్ వస్తాయి ఇప్పుడు. అప్పుడు హైపర్బోలా అని కంక్లూడ్ చేసాము, ఇది హైపర్బోలా అని చెప్పాము, గుర్తుందా? ఏఎక్స్ స్క్వేర్ ప్లస్ బిఎక్స్వై ప్లస్ సివై స్క్వేర్ ప్లస్ 2gx, ఈ కోనిక్ సెక్షన్స్ చేస్తారు కదా. సో దిస్ ఇస్ హైపర్బోలా. So can you just do one thing? Can you just revise conic sections and come back tomorrow?
Yes,
Yes,
sir.
sir.
And also AX graph. AX graph revise చేసి రాగలుగుతారా?
Yes,
Okay,
sir.
All right. Vignesh, you are saying something? I'm unable to hear you.
Okay, sir.
All right. All right. Try చేయండి. టైం తీసుకొని, anyway tomorrow is Sunday, right? No, tomorrow is Saturday. Yeah. So we'll have class tomorrow, but you revise acceleration graphs, AX graph, and come back so that we'll advance this problem to, we'll eventually modify this problem and go towards the advanced level problem. All right, basic problem నుంచి modify చేస్తూ advanced level problem కి వెళ్ళిపోదాం. But provided you revise what you have done. Revise చేయకుంటే I will have to repeat everything again and again, which is waste of time. We will be losing time. ఆ టైంలో మనం మంచి ప్రాబ్లమ్స్ చేయొచ్చు. All right. If we meet for half an hour every day, effective half an hour, in that half an hour, if we do good problems, that's quite a progress. But if we are just doing what we have done already, so that is redundant, kada? That's something which is done already, is we are doing it again means it's redundant. Okay, anyways. So in terms of pseudo force మాట్లాడదాము. AX graph మాట్లాడినప్పుడు, when I release a particle over here, what will happen to the particle? We said because the acceleration is positive, particle will go towards right and gain speed. అదే పార్టికల్ ఇక్కడ వదిలేస్తే particle go towards left, because acceleration is negative, particle go towards left. That is what is happening here. Rod is rotating like this. If I release a particle here, because of pseudo force, it is going towards right. If I release a particle here, because of pseudo force, particle will go towards left. We also discussed what happens to the particle if I project the particle towards right with velocity v naught. Velocity తక్కువ ఉంటే, it will go till here, stop and come back. Same thing over here. If I project this particle velocity v naught, pseudo force is towards left, so acceleration is towards left, particle will start retarding, it can go to certain extent and come back. Once it stops, there is pseudo force acting on it, because of it will come back. So particles go ahead, stop and come back. But once the particle crosses this point, crosses this origin, my acceleration is positive, it will go to infinity. If it crosses this point, my pseudo force is positive towards right, which will take it to infinity. All right. So you just revise AX graph ఒకసారి revise చేసిరండి. We'll plot VX graph for this problem and we'll go to this advanced level problem. All right. We have covered MSET, we have covered NEET, we have covered mains. But we'll do one thing. When a BPC batch is not there, we'll do that problem. We'll go ahead with the syllabus tomorrow in this class. When the BPC batch is not there, sometimes in the evening you have got only MPC students attending the class. That time we'll go for advanced level problems. All right. Any doubts so far, students? Okay. Now look at the students. I'm getting velocity to be root 3 omega naught L naught. Now what is the velocity? That is velocity along the rod. Is it the total speed of the particle? No. It is rotating with omega like this. It will have a tangential speed into the plane, which is r omega, which is 2L times omega. So I'll have tangential speed like this, radial speed like this. So resultant will be net total speed will be resultant of this one, tangential and radial. Radial ఇంత ఉంది VR, tangential ఇంత ఉంటుంది VT, r omega ఉంటుంది. So this square plus that square under root will give me the total speed. All right. So with respect to this reference frame, particle is not moving tangentially, particle is just going radially outward with respect to this reference frame. But with respect to ground frame, particle is going tangentially కూడా వెళ్తుంది, స్పైరల్ పాత్ వెళ్తుంది. Going in a spiral path, which is called logarithmic spiral.
సార్
Yes.
మనం ఒక లైన్ రిఫరెన్స్ ఫ్రేమ్ తీసుకుంటే అది పైకి వెళ్తుందా లేకపోతే ఓన్లీ ప్లేన్ మీద రౌండ్ గా తిరుగుతుందా?
ఇలా రొటేట్ అవుతుంది.
అక్కడే ఉంటుందా లేకపోతే ఏం పైన డిస్టెన్స్ స్పైరల్ గా వెళ్ళుకుంటూ పైకి వెళ్ళదా?
పైన నుంచి చూస్తే స్పైరల్ వెళ్తుంది, పైన నుంచి చూస్తే. కానీ ఒకవేళ జస్ట్ ఇక్కడ ఆపేసాను, పట్టుకుని అనుకో బాల్ ని, బీడ్ ని, అయితే ఒక సర్కిల్ లో వెళ్తుంది ఇది పార్టికల్.
ఓకే సార్.
పైన నుంచి చూస్తే సర్కిల్ ఉంటుంది, బట్ ఇలా చూస్తే ఇలా ఉంటుంది. Alright, omega is vertically upward. Omega ఇలా ఉందంటే my sense of rotation is anti-clockwise when seen from above or clockwise when seen from below. Alright, we'll discuss this tomorrow or in the next class when you have only MPC students. We'll go ahead with the syllabus tomorrow. We'll mostly start work for energy in half an hour tomorrow. No, there are some good questions to be done. We'll do those questions and we'll move on to the syllabus. But there is one thing which I haven't covered, banking of roads. So banking of roads will be done once we are deep into work energy. All right. So don't worry about it. We are going to leave nothing. But the thing is, there are some good problems on conical pendulum and circular motion based on circular motion. I'll send that problem to you. You try those problems, and that this sheet, whatever I'm going to send, is for IIT students only, IIT aspirants only, not for NEET. For NEET, there will be a different worksheet, but this is for only IIT aspirants. This is only for the IIT aspirants. All right. The worksheet which I'm going to send, of course, I'll mention in that, but I'm going to send a worksheet, separate worksheet, one for IIT aspirants, one for NEET aspirants. All right. Don't be confused. NEET aspirants, don't be demotivated looking at the problems of IIT aspirants. Adi meekosam kaadu. You will have a separate worksheet for you, which are NEET-based questions. All right. All right. Let's stop here, students. You have a class next. Sir would be waiting now. Bye, everyone. Have a great day. Join the next session.